Hello and welcome to SudoKanard. We're here to solve this puzzle by Australian author ChocChip, who's a regular viewer of the channel. And so this is a puzzle called the Mankey, a reference to a Pokemon. I put a picture of the Pokemon here. So the puzzle follows three rules. One of them is killer Sudoku. The sum of all three digits here is 8, and here it's 9. There's also little killer. Those clues give the sum of digits along diagonals. There. And then we have a Renban lines, which means that on those lines, on such a line we have 5 consecutive digits, all distinct. For example, they could be 1, 2, 3, 4, 5, from 2 to 6, 3 to 7, etc. Here, 3 consecutive digits in any order. And that's it. So I remember trying this puzzle in a distant past and ending up completely stumped. So ChocChip asked me if I could give it another go, and here we are. So we have some given digits actually, and 6 will be 2 plus 4. If those digits are consecutive, they can't include a 3 because 3 would have to come with a 2 or a 4. So that is a 3. Here we have a 2, so this is 4, this is 2. 7 could be 1, 6, but actually it could never be 1, 6, or like this, because then 3, 4, 5 wouldn't go on this Renban line, and 7, 8, 9 could not go on this Renban line either. So that's 3 and 4 actually, and 1 is here. We have all digits from 5 to 9 here and there. And we have 3 of them here, which means that 7 is one of them, because it's either 5, 6, 7, 6, 7, 8, or 7, 8, 9. And I think this is all I can do in this part of the grid at this point. 9 has 3 possibilities, which are 1, 2, 6, 1, 3, 5, and 2, 3, 4. We can see that there's always a 1 or a 2, and because of that, neither 1 nor 2 goes there. So 1 or 2 must go here, and 1, 2, 6 is impossible. So those are from 3, 4, 5, and 3 is in one of, and 3 is one of them. And those are not digits. Oh, this is a Renban with 6 digits actually. And an interesting point here is that this digit here is different from all digits here and this one, so that this digit must be somewhere here. That's really interesting, because 1 here and there would never work, because we would have 3, 4, and 5 here. 2 doesn't work for the same reason. 3 doesn't work for this obvious reason, so that this is 4 or 5. If this is 4, then 5 has... If this is 4, let's just ponder what is happening. If this is 4, then 4 is in here, so that this is a 2, 3, 4 triple. 1 will be there, and we have all other digits here. That appears to work. If this is 5, then 5 is here together with 1 and 3. 2 can't be along the Renban, but all other digits can be along the Renban. So that both options appear to work. This digit is in here, and this is 1 or 2. And perhaps I should use some coloring to mark the fact that this digit appears somewhere there. And it could be this 4, or it could be a 5 somewhere in here. So I think this 40 looks very much like something that we used to disambiguate at the very end. Now, what else? This here looks similar to that. I don't have 1, 2, 3, and I don't think that 4 here would work, because 4 will come with a 5, and the 4 or 5 here wouldn't be possible. That wouldn't be possible either. So this is between 5 and 7, like the 5 and 9, sorry, like on this Renban, and 7 has to be on this Renban line, and we have a 7 somewhere here, 7 somewhere there, but we're probably supposed to move on to this part of the puzzle. So 8 has 2 possibilities, which are 1, 2, 5, and 1, 3, 4. So there's always a 2 or a 4. So the digit from 2 and 4 will be here. And the rest will be from 1, 3, 5, and there is a 1 in there. And an interesting part here is that the common digit here and there, that I will just color purple, I think, will have to appear somewhere on this Renban lines, Renban line singular. But first, I'd like to address this. I think that 1, 2, yes, 1, 2, 5 is impossible here, because on a Renban line of length 5, you always need to have the 5. Because let's imagine that 5 is here. Then the consecutive digits available are either 1, 2, 3, 4, or 6, 7, 8, 9. And there are sets of at most 4 consecutive digits. So it can't just fill a whole Renban line like this. So that this is actually 4 with 1 and 3. 2 can't be along this line for the same reasons as before. And this is 2, and now this is 1, this is 2, and this is disambiguated. This is 3 or 4, and more precisely 3, 4, 1 and 3 here. And this is 4, considering that this digit had to appear somewhere there. And there has to be a 4 in here. 5 also will appear. This will be, oh, actually there has to be a 3 as well. 3 will be somewhere here. This will be 3, 4, 5. And I don't think that the coloring serves any purpose at this point. But first I will remark that 3, 4, and 5 must be here for the same reason. Right, so that's the nice beginning with 1, 2, 3, 4 in many places. And with this and that, I can place a 5 here, which won't be here. And there will be something about 6, 7, 8, 9. I'm also noticing that 5 goes here. So those are 6, 7, 8, 9. Those are 6, 7, 8, 9 as well. 1 and 2 must be somewhere on this part of the row. What about 1 and 2? 1 and 2 can be here, or they can be here. So basically, those are 3 Renban lines of length 2. One of them is 6, 7, another one is 1, 2, the other one is 8, 9. There's a 2 somewhere in here. So it looks like those 20 clues should be addressed pretty soon. Oh, 5. 5 is somewhere here. So this is 5, 6, 7. And we get 8, 9 pair here. Oops, not on the outside of the grid, not in the margin. So now we have 2 consecutive digits here, 2 here. And are those necessarily consecutive? I think not. So what we could have is somewhere 1, 2, somewhere 3, 4, somewhere 8, 9. Like a 9, 8, 7, for example, or 1, 2, 3. Or 1, 2, 3, 4 could be split. Something like 3, 2, 1, 2. Could it? Or let's try something. Let's say this is 2 and 3, in which case this will be 8, 9, and this will be 1, 4, and we could very well have a 2 or a 3 here. That would work. So the 1, 2, 3, 4 could be split. So that doesn't seem to be too constrained. There's a 5 here. I've been missing that, considering those 5s, and now there's a 5 here. All right, so 1, 2, 3, 4, 5 was actually given in quite a number of places. And now, by the same reasoning as in here, 5 is somewhere here, so this is a 5, 6, 7 triple. We get an 8, 9 pair here, and a 6, 7 pair there. And now this 20 clue becomes more constrained. Here we have digits from 6, 7, 8, 9. And 6, 7 are both excluded from those sets, so on this column the second 6 or 7 must be here. And let's have a look at the maximum possible here. It would be with 7, 2, 7, 5, and that's 21. Is that correct? Yes, this is correct. So we have only 1 degree of freedom along this particular clue, so 5 here is impossible, 3 here is impossible. So 2 of them will be maximum, and the other one will be 1 less than the max. This digit will appear somewhere along with the 2. We have 1 and 3 somewhere here, most probably with a late disambiguation, and 6, 7, 8, 9 here. And then And then what I'm seeing is that this 8, 9 here is not here, so it must appear somewhere there, which creates a virtual pair. One digit from 8, 9 is here, the second one is here, so that this is not 8, 9, this is 6, 7. And we have an 8, 9 here, and I'm tempted to use some coloring. So this here appears there. That's the other 8 or 9. This is the same as the first. This is also the same as the first. And so we have the purple 8 or 9 and the green 8 or 9. And the green 8 or 9 appears somewhere here and somewhere there and somewhere there. So this will have to suffice at this point. And something similar should be happening with 6 or 7. The green 8 or 9 is somewhere here. That doesn't seem to be that powerful. So perhaps I should address that 20 clue. Yes, here we have a minimum of 7. So the remaining 2 digits have a maximum of 13. Which means that they can be at most 6 and 7. As those digits are from 6, 7, 8, 9. Those digits must be from 6 and 7. And regarding the coloring, it means that the green 8, 9 is here. And that this is an 8, 9, and I said earlier that those 6 cells would be split into a 1, 2 pair, a 6, 7 pair, which has to be, no, it can't be here now. Because of that. One, 2, 8, 9. Oh, no, I was wrong. 6, 7, 8, 9 can be split, and they have to be split actually. Exactly like I said about 1, 2, 3, 4 in this area. 1, 2, 3, 4 could be split, and in this area 6, 7, 8, 9 has to be split. So here we have one digit from 8, 9. And here we have another digit from 8, 9. So this can't be 8 and 9. So 9 can't be here. 9 will have to be there. And 9 is the purple digit. And 8 is the green digit. 8, 9. How cool is that? Here I will pencil mark 1, 3, 8, just because I can. And there's 18 here. This is from 6, 7. This is from 6, 7, 8. This is 8, the green digit. And 8 will be with a 6 or 7, which will be 7 because of the Renban line. This is 6, and this is the 1, 2 pair. So that this is 7. This is 9. This is from 6, 7. I will remove some of the coloring. And actually, the coloring doesn't serve any purpose anymore, but I will keep it for the time being. So that is definitely some progress, something I didn't find when I tried the puzzle some time ago. So this is 10. This plus that must be 10, so this can't be 5. This is a 6, 7, 9 triple. This is a 1, 2, 8 triple. 9, so this plus that must be 11. Oh, and we can do better than that. This is 11, this is 10, so those 4 digits have a total of 21. Removing those 2 digits, we remove 13, which means that this plus that is 8, so that this is 3, this is 5, this is 4. Beautiful. And now we can complete with 7 here and 6 there. So that the disambiguation between 6 and 7 does not need any coloring. Not that coloring be a bad thing, but it's just easier than that. Now let's pencil mark. This is 1, 3, and 9. 3 is not 2, and 3 is not here. So this is from 2 and 8. Those 4 can only be here, so that this is 3. And this is from 2 and 8. And finally, those 2 had to be consecutive. And this, in turn, will have to be 3 or 7. Here we have a Renban line of length 3. Finally. So now what about this? So, perhaps 40, I think 40 will be the final disambiguation. But let's have a look at this. So this contains 2 consecutive digits. So one of them has to be an even digit, the other one must be an odd digit. 8, so 4 and 6 are not available. 8 won't work because 7 and 9 are not available, so that the even digit is a 2. So this is either 1, 2, or 2, 3. And 3 is not here. And because this is from 1, 2, 3, the Renban line here can't be 1, 2, 3. It has to be 9, 8, 7. And this is 1 and 2, with 8 there. That's the 6. That's a 5 up there. And this is also from 1, 2, 3. Oh, here we have a triple. Now I'm seeing that 8 here has to be somewhere there, so that 8 on this row is here. And I will remove the coloring, even though it doesn't serve any purpose anyway. On this row I need 1, 2, 3, 5, and this can only be a 5, so that this is 3. 3 is there. Oh, and I see why there is a final disambiguation. That's because of this deadly pattern. So this 40 should just be used for that, or perhaps for something else. Yes, here there is still something ongoing. Here we need 4, 6, 8, 9, but 8 is not here. 4 is not there. So at this point there are multiple solutions. So 40 will just disambiguate all of that. Those 4 digits sum to 23, so that those 4 digits should sum to 17. And 17 is almost the minimal option. The minimal option is 16. So we have only 1 degree of freedom up, so that this has to be a 4. That's the only option, and this has to be a 9. 5, 4. So say, oh, 17, no. Oh, I was wrong. I said there's only one degree of freedom up, so this has to be a 7, and this has to be a 4 indeed. 5, 4. So here, those 3 digits sum to 15, and we complete to 17 with a 2 here, and the rest should be straightforward Sudoku elimination. This is a 6. This is 5. This is 6. This is 1. This is 3. This is 2. This is 1. This is 9. This is 2. This is 8. This is 9. This is 8. This is 7. And finally 7 and 6. And what is happening? Perhaps I should remove all the coloring. And when I say what is happening, I mean what is not happening. Did I make a mistake? I just checked that. So 20. This is 40, definitely. This is 20. This is 20. The Renban lines are indeed made of consecutive digits. 2, 7. Did I write wrong digit at some point? This would be a very Kanard thing to do. Well, I don't know why the fireworks don't trigger, but I think that my resolution is correct. All in all, it was a very, very nice puzzle with some tricky interactions between the clues, but they were the trickiest part was the coloring with 8 and 9, and understanding the part about a series of 4 consecutive digits having the possibility of being split. This is the part where I could go wrong, and maybe this is the part that stumped me in my previous attempt. Well, I guess we'll never know. Anyway, thanks for watching this video. Thanks, Adam, for the puzzle, and see you someday on SudoKanard. Alright, so just after shutting down the video, I saw where I went wrong. I completely messed up the 6s and 7s, so I just I went back to the place I messed up, where I repeated the 7s on this column. So let's just rectify all of this. So this is from 1, 3, and 9, and 3 is not here. This is from 2, 4, 8, 8 I said, but 4 is not here, and 4 is not there either. So this is 4, this is 3, so a lot seems to be happening just the same. As I was mentioning, 8 can't be here, so those will be from 1 to 3, so that this can't be 1 to 3, and it has to be 7, 8, 9 indeed. This is 8, this is 7, this is 6, this is not 8, this is 5, this is also from 1 to 3, but it can't be a 2. This is 1 and 2, this is 8. And now 3 is somewhere here, so that's not a 3. And this has to be 8. With this 1, 3 pair, this becomes a 2. And that's not a 3. This is actually this is 1, this is not, this is 2, this is 9, this is 3. And we get this deadly pattern. This is a 5, this is a 3. So we get basically the same disambiguation needed. Here we need digits from 4, 6, 9. So this is from 6, 9. This is from 4, 6, 9. Here we need digit from 4, 6, 8. So that 8 is here. And this is from 4, 6. And then we address this diagonal 40. At this point we have 11, 24, so those digits must sum to 16, and 16 is the minimum value this time, so it's even easier. And I do hope I will get the fireworks this time. This is 6, 7, 9, 6, and 9 there, yes. And I get the congratulations for the extended video. So this will be a first on SudoKanard. I will edit a video to just concatenate 2 videos to join them. So thanks for watching this video and see you someday on SudoKanard.